Hello everyone. In this particular session, we will understand how to perform bit reversal of any given 8 bits of data. So in this particular example, the 8-bit data we are considering is hexadecimal value 14. 14 in binary will be nothing but 0001 0100, and the aim of this particular code is to convert it into 0010 1000. Okay, that is, we want to reverse the entire 8 bit of data or flip the bits in such a way that what is the output we are expecting, it is 28. Okay, so let's just continue here. We have chosen register R0 to hold the final output, and register R2 is used as a counter. It is storing a value 8 because we are trying to flip 8 bits of data. So now let's see if this particular code has any errors. No. So we'll proceed with debugging. The very first instruction is a simple move instruction which stores a hexadecimal value 14 into register R1. Okay. Next we have initialized the register R0 with the value 0. Okay, and R2 is updated with the value 8. Initially R0 value is 0. It means all the bits of R0 are actually 0, but throughout I will just be showing the last 8 bits because our focus will only be on the last 8 bits. Okay, if you are considering 32-bit reversal, then you need to consider all the bits. As of now, we will just focus on the last 8 bits. Okay, so what they are saying is perform logical shift left on this particular R0 by 1 bit position. What does that mean? This is how logical shift left performed. And the last bit here is actually filled with 0. Why exactly I'm doing that? In every iteration, last bit is updated, which is then shifted to left, so that the last 8 bits of R0 is now updated with the reversed bits of register R1. Okay, let's see how it is done later on. For now, we'll just continue here. AND operation between R1 and the value 1. Okay, what is R1 content? It is 14. Because it is 14, even if R1 is a 32-bit register, all higher bits are actually 0. Only the last 8 bits are to be considered. That is, the last 8 bits are something like this. This value is supposed to be ANDed with 1. What is 1? If you are considering it as an 8-bit data, 1 here and all zeros. Okay, so if you're performing AND, we need to know that each bit position is considered. Okay, and whenever there is a common 1, only in that particular case that particular bit position will get the answer as 1. But in this particular case there is no common 1 here, correct? Either it is 0 1 or 0 0. So because of which we will get the answer as all zeros. When do you think there will be a difference in this particular answer? Only when the last bit considered in the case of R1 has a value 1, output will change. Otherwise, output will always be 0. So what are we doing here? We are performing OR operation between R0 and the result. See, this will be stored here. We are performing an OR operation between this and the value already stored in R0. We know R0 is initially 0. So what is the result? It is again 0, because OR output will be 1 even if at least one bit position has a value 1. So let's see if that is the answer you get. So as you can see here, the result of OR operation R0 is still 0. But what happens in the next case, that is move R1, R1, LSR hash 1. Here we have our R1 as nothing but. What happens if I perform a logical shift right? Entire content is shifted to right side and last bit is discarded. So the result will be nothing but 1 0 1 0, which is nothing but A. Okay, so you'll see a result A here in R1. Okay, let's see that happening. Yes, that's the result we obtained. And next what we are doing is we are subtracting R2 by 1. Why exactly this is done? Because we have already checked the last bit of R1 which was 0, and that we have updated in the register R0. Because one iteration is complete, we are subtracting R2 by 1, because of which result will be nothing but 7. Yes. And now branch if not equal to loop. What this will do is it will check the CPSR Z flag. It is set as 0 because in the last iteration R2 result was not 0. So here this will check Z flag because it is 0. Branch will happen to this particular label loop. Okay, and again these instructions are executed. Okay, let's see that happening. Okay, our one iteration is complete and our result is still 0. What exactly happens in this particular step? The result which was 0, again we are performing logical shift left, but because 0, when you perform logical shift left, the inserted value is again 0 only. So you will see that the result of this particular instruction is still 0, or R0 is still 0. Let's see that happening. Yes. Next operation is AND operation. What is our new argument? It is A. The result is still 0. And you know the next operation is OR between R3 and R0. And as you can expect here, R0 that you obtain here is again 0. That's what you observe here. R1 is again shifted right. Our value is this. When you shift it to right side, what will happen? So this is the result of the logical shift right that we performed, and we have a new value for R1 which is nothing but 5. Okay, let's see that happening. Yes. And then what we are performing is we are just subtracting R2 to confirm that one more iteration is complete. Let's see that happening. And here R2 is now set as 6 due to the subtraction. And yeah, the loop is repeating. The first step anyway results in the same answer. Okay, so in this particular case, what is the new value of R1? So what do you think will happen when an AND operation happens between 5 and 1? So let's see that happening. R3 value now should be equivalent to 1. Let's see if that is true. The first step, what has happened? R0 has retained the value 0, and now when I perform AND operation, the result stored in R3 is 1. Okay. So next step what we have is OR operation between R0 and R3. So what should happen here? As you can expect, it's an OR operation. So the result here will be 1. Let's see that happening. Yes. Next we have logical shift right. Okay, to be performed on R1. What is the value of R1 now? That is nothing but 5. What happens if I perform logical shift right here? It will be nothing but 2. Let's see that happening. Yes. And next R2 value is subtracted by 1. It was 6 here. So next we have the value as 5. Okay. And you branch back to the loop. We know R0 is this value which is 1. What will happen if I perform logical shift left? Entire content is shifted to left. Let's see that happening. Yes, so value 2 is stored in R0. So what is the new value of R1? The value is actually 2. And when this is ANDed with 1, what is the result we get? Okay, and when that is ORed with R0, what is the new value of R0? It is nothing but, now what will happen is the result we obtain from this particular OR operation is 0. Okay, so let's see that happening. So now what will happen after this instruction, that is LSR? Our value of R1 which was initially 2, when shift right performed, the answer we get is 1. And again R2 is subtracted by 1, so R2 will become 4, and we are branching back to the loop. Let's see all that happening. Okay, so new R1 is 1 and our R2 is 4, and we are branching back to the loop. Next step what we have is again R0, we are performing logical shift left by 1. What happens if you perform logical shift left on this again? This entire content is shifted to left, so the answer 100 is obtained. And what happens in the next step? Argv1 content is 1 now, and we have ANDed with 1. So what will be the result of that? 1. Okay, and what is the value of arg0 currently? It is nothing but 4. So what should be the result of this OR operation? It is nothing but, okay, this is what is stored in arg0. Let's see all those things happening. Okay, what should happen next? We should again perform logical shift right by one time on arg1. Previous arg1 value was 1. What happens if you shift it right now? The answer will be 0. Okay, and what you will notice is every time after this particular step, since the value of arg1 is 0, any number of logical shift right will just retain the same value, that is 0. That value here, okay, arg1 is finally 0, and we are just subtracting r2. It was 4 previously, it will become 3, and we are branching back. Okay, but what will happen here? What was the answer stored in arg0? 0, 1. Okay, so what should happen after the logical shift left? The entire content should be shifted left, so the answer we obtain is 1010. Let's see if that is true. Yes. Next we are supposed to perform AND operation between arg1 and 1. So what is our current arg1? 0, and it remains same throughout the next iterations, and the result we obtain after ANDing it with 1 is nothing but 0. And you will notice the same value of r3 for the next sequence of iterations. Okay, but what keeps on changing is arg0 value. So what is arg0 currently? So what's the result we expect here? Okay, so the output that you have to see after the OR operation is 1010, which is nothing but A. We know that already arg1 in the previous iteration we got it as 0. Okay, any logical shift right will retain the same value. Okay, and we'll subtract r2. What happens when you subtract r2? Value stored. Okay, and we branch back to the loop. Previous value of r0 is 1010. When you shift left, what happens? Okay, and what happens in our next step? See, AND operation remains same because r1 is still 0, so r3 will still be 0, but r0 has changed. So what is our new r0 value? Because it's an OR operation. And let's see that happening here. As you can see, the result of this iteration is 14 in r0. r1 remains at 0, okay, while after this particular step r2 decrements. Okay, there is last one iteration pending. Let's see what happens there. So we know r0 is supposed to be left shifted by 1. Our current r0 value is, so when you left shift it, what happens? Answer you get is something like this. Okay, and then AND result will be 0, or result will just retain, and this is the result of our OR operation. Let's see that happening. Okay, and we have to subtract r2 by 1, which results in 0, and this particular branch will not occur because r2 is 0, which sets the z flag as 1 here. Okay, so because of which we enter an infinite loop. So the result that we have obtained at the end of all this 8 iteration is 28. Is that the correct answer? Yes. Okay, so that's all about bit reversal of an 8-bit data. What if it was a 32-bit data? Then we would have to make minor modification that change this to 32. Let me change the value considered here. Let me take a simple value 1 here. If it is 1, a 32-bit value 1, how will you write it in binary? Something like this. All remaining bits are actually 0. If I have to perform bit reversal on this, okay, then what's the result supposed to get? The result I'm supposed to get is 1 at the MSB. All remaining bits are actually 0. So what is this? 8 and all zeros. Okay, this is in hexadecimal. Okay, let's see if I change the counter value from 8 to 32, will I get the same bit reversal output for a 32-bit data? Let me just save this updated value and debug my code. The steps remain same, so I'll just show the final output here. Okay, as expected, 8 and all 0 is the final result shown in arg0.